Hello Bobcats. Today we are going to discuss Lewis dot structures of covalent compounds. So let's go through the rules and then we'll do some practice of writing Lewis dot structures for covalent compounds. The first thing we need to be aware of is that first, you always count the number of valence electrons available in the compound. So let's take an example. Let's look at carbon tetrachloride. And I'll use red here. So CCl4. Now in this case, we have one carbon, so I write 1 times the 4 valence electrons that carbon has, plus we have 4 chlorines, so that's going to be 4 times 7 valence electrons that each chlorine has. 4 times 7 is 28 plus 4, so that's 32 electrons available in this compound to use to draw the Lewis dot structure. You cannot use less or more. You have to use those 32 electrons when you're drawing the structure. Okay, so the next step would be to draw a skeletal structure with the least electronegative element in the center, the structure should be as symmetrical as possible. And then bonds placed between each element with bond, say a bond, not bonds, but a bond placed between each atom. And then one thing that's important to remember is that hydrogen is never in the center. Because hydrogen only needs 2 electrons, and so you can't put it in the center because the bond already gives it 2 electrons. So let me draw, we have carbon tetrachloride, so carbon is the least electronegative or less electronegative than chlorine. So I'm going to put carbon in the center, and I'm going to put a chlorine, 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 chlorine. So it's as symmetrical as possible, and I've put a bond between each of the atoms. Now in this case I've used 2, 4, 6, 8 of the 32 electrons. So the next step was to place extra electrons, step 3, is to place any extra electrons in pairs around the outer elements. starting with the most electronegative. Until all electrons are used. Okay, so we go back to the structure. We have carbon, chlorine, 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 and chlorine. So chlorine, these are all the same elements, so they're all the same electronegativity. So we're going to be putting extra electrons in pairs around the outer elements until I use all of the electrons. So I've used 2, 4, 6, 8, and I go 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I've used all 32 electrons. The last thing you need to do, or one of the last things you may need to do, is check, or the next thing I should say is to check for octets. Now there are exceptions, and let me write those down for you. Hydrogen only needs 2 electrons to fill its outer energy level. Beryllium only requires 4 instead of 8. Boron only requires 6 electrons instead of 8. And then we have phosphorus. Phosphorus can have 8 electrons or 10 electrons, and we'll talk about this expanded. Octet is what it's called. And then sulfur can have 8 electrons or 12 electrons, and we'll talk about that. So let's look up here and see if we have an octet. Now remember, each bond accounts for 2 electrons around that element. So if I look at carbon, I have 2, 4, 6, 8. So carbon has its octet. And then I'm going to look at this chlorine, and if this one has the octet, the others are the same, so they'll have an octet also. So that's 2, 4, 6, 8. So each one has 8. So they all have octets, and I've used only and all of the 32 electrons. So that's a valid structure. Now, what happens if you run into a problem where you don't have an octet? So that's step number 5. And with step number 5, if all electrons are used, and octets are not met, then I have a little saying. I say, then take from the rich and share with the poor. Not give, but share with the poor. So you take from the rich and share with the poor. Now, what is that going to look like? So let's look at carbon dioxide in this instance. So we're going to do carbon dioxide. First thing, remember, is count the valence electrons. So I have 1 carbon, and it has 4 valence electrons. And then I have 2 oxygens, so 2 times oxygen's 6 valence electrons. So that's 12 plus 4. That is 16 electrons that I must use. Now, carbon is least electronegative, so I'm going to put carbon in the center. So I'm going to write carbon, oxygen, oxygen. I've used 4 of the 16, so I start placing pairs until all 16 are used. So I go 2, 4, 6, 8, 10, 12, 14, 16. So I've used all 16. Now I check the octet, and in this case, this has 2, 4, 6, 8. The oxygen is good. This oxygen has 2, 4, 6, 8. But this carbon has 2, 4. So like I said, I'm going to take from the rich and share with the poor. So I'm going to take these 2 electrons and share with the carbon. And so what I get is an oxygen double bonded to a carbon, single bonded to an oxygen. This will have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Now let's make sure I'm still using the 16 electrons. 2, 4, 6, 8, 10, 12, 14, 16. Check the octets. 2, 4, 6, 8 for this oxygen, 2, 4, 6 for the carbon, and 8 for this oxygen. So the carbon still needs 2 more electrons. So I'm going to take from the rich. Now this oxygen is not as rich as this oxygen with electrons. So I'm going to take from the rich and share with the poor. And so my structure that I get is going to be a carbon, double bond oxygen, set up like this. Now let's check and see if I've used all 16 and that all octets are filled. So 2, 4, 6, 8, 10, 12, 14, 16. Then 2, 4, 6, 8 for the oxygen, 2, 4, 6, 8 for the carbon, and then 2, 4, 6, 8 for this oxygen. So this is the structure for carbon dioxide. Now when we're doing compounds, there's some patterns. Now remember, these are common patterns. They're not necessarily rules. They're just patterns to help you out. So some common patterns when doing structures would be carbon will get 4 bonds, almost always. Nitrogen tends to have 3 bonds and 1 lone pair. Of electrons. Oxygen tends to have, now this is not a rule, this is just a tend or pattern, tends to have 2 bonds and 2 lone pairs. And then the halogens, like chlorine, fluorine, iodine, and bromine, halogens, tend to have 1 bond and 3 lone pairs of electrons. Okay, so those are some patterns. And if you think about it, it makes sense, because if I take my nitrogen and I draw the electron dot structure for nitrogen, it's 1, 2, 3, 4, 5. You'll notice that this is paired up, so there's no bonding that will occur here. But I can have a bond here where an electron is shared here, here, and here. So that's 3 bonds and 1 lone pair. And so that's where this pattern comes from. The other thing is carbon bonds to carbon first. So if you have more than 1 carbon, you bond the carbons first together. So carbon bonds to carbon first. Then other elements will go around. So there's some patterns. So those are the rules. Let's do some practice with this. So we're going to practice. First, let's practice with ammonia. So let me write practice here, or Lewis structure practice.